ödüllerimizi takdim edeceğiz. Sahnemiz hazır olmak üzere. Online bağlantımız da hazır. Moderatörümüz de hazır. Ceketini giymeyecek herhalde moderatörümüz. Peki. Şunları alırsak ben hemen videoya pasımı atayım. Efendim, pek çok sponsorumuzun tanıtım videosunu panellerimiz öncesinde sizlerle buluşturduk. Onların desteği kuşkusuz son derece önemliydi. Böyle etkinliklerin gerçekleşmesinde sponsorlarımız bize için çok kıymetli. Şimdi de son sponsorumuzun videosunu izleyeceğiz. Bronz sponsorumuz Enerjisa'nın tanıtım filmi sizlerle.
Dijitalleşme, iyi bir gelecek. İnsan odaklı teknolojiyi kullanarak dijital dönüşüme öncülük etmek çok daha iyi bir gelecek. Dünyanın ilk patentli dijital dönüşüm modeli Eternal'la dijital teknolojileri kullanarak kesintisiz sürdürdüğümüz operasyon ve süreçlerimizi hayatı kolaylaştıracak şekilde dönüştürüyoruz. Herkes için daha iyi bir gelecek. Enerjisa, Türkiye'nin enerjisi.
Evet, Enerjisa'ya da destekleri için teşekkür ediyoruz. Efendim, günün son konuşması için daha etkili yapay zeka inovasyonuna doğru diyeceğiz ve moderatörümüz AYPA Başkan Yardımcısı, AI kurucusu Sayın Gökhan Varan'ı alkışlarınızla davet ediyorum. Buyurunuz efendim. Hoş geldiniz. Gökhan Bey de az sonra bizimle konuşmacımız. Carnegie Mellon Üniversitesi Yapay Zeka ve İnsan Makine Etkileşimi Enstitüsü öğretim üyesi Sayın Profesör Doktor John Zimmerman'ı buluşturacak. Söz sizde, buyurun.
Teşekkür ediyoruz Duygu Hanım. Kıymetli konuklar, dijitalde bizleri izleyen kıymetli izleyiciler, 2 günün ardından yoğun bir programın sonuna geldik. Kapanış oturumunu birlikte yapacağız. Şimdi yabancı bir misafirimiz olacak. Önce Türkçe konuşmak, sonra izninizle İngilizce kendisini tanıtarak oturumu tamamlamayı düşünüyoruz. Sabrınız, bizlerle olduğunuz için ve burada bizlere eşlik ettiğiniz için bu heyecanı çok teşekkür ediyoruz. İzninizle ben şimdi misafirimizi tanıtmak istiyorum. Ladies and gentlemen, it's my distinct pleasure to introduce our esteemed guest, Professor John Zimmerman, Tang Family Professor of AI and Human Computer Interaction at Human Computer Institute of Carnegie Mellon University. Professor Zimmerman is a leading expert in the field of AI with a distinguished career that spans over 4 decades. His groundbreaking research has significantly advanced our understanding of AI and its applications across various industries. Professor Zimmerman has published numerous influential papers and has been honored for his contributions to the field. Professor Zimmerman, as most of you remember, was with us for the previous AI Tomorrow summits in 2022 and 2023, with the presentations in 2022, Closing the Innovation Gap in AI, and in 2023, Better Paths to AI Innovation. Today, we are privileged to hear from him as he shares his insights and vision for the future of AI, with his presentation named Towards More Effective AI Innovation. Please join me in welcoming Professor Zimmerman. Professor, hear me?
Hi. Yes.
Yeah, welcome. You have the floor.
Thank you. I'm very excited to be here today to talk to you about some of the work we've been doing on AI innovation. So as mentioned, I've been working on AI systems for a long time, 25 years. This is the very first system I worked on back as a TV show recommender for Philips back when Xena Warrior Princess was a first run TV show. Since then, I've done a variety of systems. One of my favorite systems was the person, place, time view. We would learn the pickups and drop-offs of busy families, and we could predict when and where everyone was going to be. And the system could detect when was there a child that probably should be getting picked up by their parents, but no parent was moving towards the child. So it was like a smoke detector for forgetting your kids. Some of my current work looks at smart classrooms. We instrument these rooms. We watch teachers teach. We watch how students react to the teaching, and then we provide feedback to teachers to really help them improve their performance. I also do a lot of work in healthcare. This is an example of a decision support tool that helps cardiologists decide which patients should get mechanical heart. So it's really thinking about putting AI in these life and death decision situations. About 10 years ago, in addition to sort of working on systems, I started to really look at what's the process that we use to create AI systems and tried to think of AI as a design material. At the time, pretty much you needed to have a PhD in machine learning to create these kinds of systems. And I was really interested, how can we bring people with more of a creative bent into thinking about what AI products and services might be. And to sort of just frame this, I want to start with the idea that AI is actually amazing. One of my favorite examples is the Kiva robots used in the Amazon warehouses. These robots drive around, they drive under shelves, they spin up and lift a shelf up, and they can drive the shelves everywhere in the warehouse. And you have pickers who are people, and they pack the boxes. And the idea is every time a picker puts their hand out, the item that they need is always available. And the robots totally organize this in a non-human way. So something like red sweaters aren't all in one place. They're spread all over the warehouse. And it becomes a space where only robots can work. This technology has worked so well that Amazon bought the company, and they don't allow anyone else to use this. Another example I really like is smart pricing from Airbnb. They make a prediction of what any unit will rent for. What's the maximum you can charge and still have it rent? And to me, this is an example of giving everyday people CEO level insights. Finally, recently, we had the emergence of systems like ChatGPT, so large language models, Gen AI foundation models, and these have been very transformative because they're providing pre-trained models. So now it's less about, can I build this model, but can I get one of these pre-trained models to create whatever system I'm trying to build? The tremendous success we've seen, especially recently, really implies that we have an effective innovation process, but we don't. So right now, about 85% of all AI projects and companies fail to reach deployment, and many fail after deployment. So it's really closer to a 90% failure rate. And as we talk to different companies, what we repeatedly hear is that data science teams and vision services customers don't want, and design innovation teams envision services that can't be built. And this is what we're trying to repair. We found that there are 4 main points of failure, and if we can overcome these, we can really improve the process. So one is that you can never get the machine learning performance that you need to situate your system. Another problem is the service you create never creates enough revenue to cover its own costs. Another big failure point is that AI systems don't solve real user needs, so people don't adopt and use them. And finally, there are issues with responsible AI. These are ethical issues of fairness, bias, privacy, or other types of unintended harm. In addition to all of these projects failing, what my team's noticed is a lot of what we call missed low-hanging fruit. This is situations where a little bit of very simple AI creates value for services and their customers. And so it's a mystery to us why these systems don't get built. I just want to touch on 2 as examples, but there's millions of these. You may be familiar with Instagram. Instagram is a company full of the world's greatest data scientists and user experience designers. Instagram really wants influencers to post, because when influencers post, they attract the eyeballs that consume ads that make money for Instagram. But interestingly, the Instagram app never learns which tags influencers always use, and it forces influencers to type these over and over again every time they post. It's unnecessary friction that is limiting the sort of opportunity space of this app. Another example is self-parking cars. So this is a feature available on many very high-end brands. It serves a tiny population of people that live in the suburbs and are afraid to drive in the city because they might have to parallel park. This is a really complicated system to build. A car has to sense if a parking space is big enough. You need to tie into the acceleration, braking, transmission, and steering systems. You need to create a policy of how to achieve parking, and then you need to measure your progress along that policy. This is a super difficult feature that appeals to very few people, but if you look at the first step, is the space big enough? The sensors to do that are already on cars. That could be available today and would benefit anyone driving in the city. Another problem we see is a lack of innovation. So I want to kind of break this down a little in thinking of the difference between invention and innovation. So an invention is like in 1963 when Philips created the cassette recorder, which is a new set of capabilities. Innovation is the ability to recognize people that need that capability and putting this mechanism in a product form that they experience as valuable and useful. So innovation is things like creating boom boxes so kids could take music to the playground, creating the Walkman, which gave people a personal music experience, or creating answering machines that allowed people who were waiting for important calls to still leave their homes and live their lives. This kind of innovation we really don't see with AI. So one question we wrestle with is, why is innovation so difficult? And we really think a core aspect of this is that teams are choosing the wrong things to make. You can look at data science as part of this. Currently, data scientists are not trained to ideate. A data science process starts with problem formulation. If you look in a data science textbook, it might have a couple of paragraphs that are basically saying, find an interesting problem. But data scientists aren't taught to think of 100 different things you might do. Now, which one of those are low risk, high value? In addition, there's a culture in data science that harder is better. So they want to work on really hard problems. They're not necessarily working on things that are particularly valuable. IBM's done some great work looking at data science in the enterprise. This is a new role. No one's quite sure how to collaborate with data scientists, and they've noticed that there's really ineffective communication, often around issues of model performance. So a data science team might say, hey, we can get model performance of 90%. Is that good enough? It seems like an A-. Maybe it's good enough. If you think of an application like automatic speech recognition, at 90%, about one word in every sentence will be wrong. So on the surface, that can seem like terrible quality, but it really depends on the application. If you're trying to produce a transcript of a trial, that is nowhere near good enough. But if you're trying to produce a transcript of a voicemail, it's more than effective at letting people know if they need to listen to this message or not. Another challenge is that no one knows what anything will cost. Currently, if you were to go to an architect and say, I have $100 million, they could tell you what they could build for that $100 million using concrete, glass, steel. We can build a building of this size that can support these types of activities. If you go to a data science team and say, I have $100 million, The only thing they can guarantee you is that they can spend your $100 million. There's no way for them to tell you what they can deliver for that. Another big problem is non-data scientists think of AI as a superhuman intelligence. And here I really want to blame the media. They really love these clickbait stories. Target knows that teenage girl's pregnant before her parents. AI is now outperforming doctors at diagnosing cancer. Google engineer says chatbot is sentient. None of these things are objectively true, and they create a bunch of misleading assumptions about what is possible with AI. The result of that is when innovation teams think about what to build, they tend to only think about really hard problems where you need nearly perfect model performance to create value. And the impact of that is the majority of the opportunity space simply goes uninvestigated. We repeatedly find that designers and other innovators really struggle to understand AI. They really want to know what can it do, but if you read the literature on AI, really the only thing it talks about is how it works. And so there's a real gap between those two. User-centered design, which is the main innovation process used in the tech industry today, does not work with AI innovation. And that is a very hard lesson to learn. AI innovation really needs to start at the center of a user experience process. If you follow a typical user-centered design, you study some user, you get an idea of what their needs are, you create some priorities. If we can address these needs, we can be transformative. The problem is that those needs are almost never overlapping with what AI can reasonably do. And so with AI innovation, you've already predetermined your solution must be AI. And so you turn your innovation team into hammers looking for nails. They see every problem as a problem that AI should be used to address. And this is a big part of why they keep making things that can't actually function. So what helps? We've been doing some work, spending time where there are innovation teams that work really well. So places like Google, Meta, Philips, Accenture. And what we repeatedly see are effective teams have internalized a bunch of abstractions of AI capabilities, and they use examples of products and services in the world as a way of effectively communicating. In addition, the best places we've been have really co-located design innovators and their data scientists. They sit together, they work together, they're sort of forced to collaborate. And when you can do that, then you really see some magic starting to happen. My own team, we spent 3 years really trying to understand AI capabilities, looking across a bunch of different industrial domains. We identified 40 AI features that repeatedly show up in commercially successful products and services. Following a taxonomy approach, we boiled this down to 8 high-level capabilities, and we really thought we had helped solve this innovation process. But interestingly, when we piloted this, we found it didn't work. Designers could definitely call upon appropriate AI capabilities, but the ideas they came up with were still not buildable. And this forced us to really rethink what the problem was. And we encountered some ideas from Google. So Casey Korzakov, she used to be the chief decision scientist at Google. She trained teams about where to look for AI opportunities. And she said, you need to think of AI as an island full of drunk people. It can do things really fast, and it can handle an inhuman quantity of information because there's lots of drunk people. But they're drunk people, so don't expect them to be very smart. So where do you need speed? Where do you need scale? But where don't you need quality? That is the rich space for AI. And so we went back and really looked at these 40 features that we saw repeatedly showing up. And we noticed that 25 of them had moderate model performance. So they were less than 90% accurate, but they were still creating value. And so this told us we really needed a design process that could help people think about, where does moderately performing AI create value? So one of the areas that I work on is the ICU. We're trying to think about, how do we situate AI in a way, in this sort of life and death context, where it creates value but does not create additional risk. So one of the things we did was just facilitate data scientists and clinicians in brainstorming about what AI might do. And it was interesting, none of these people had ever brainstormed before. We just took them through a basic innovation process. We generated a bunch of ideas, we mapped them to an impact effort matrix, and what we saw is pretty much all the ideas were really hard, and only some of them were valuable. So then we changed the way we approached brainstorming. We started by sensitizing the team to where, like, simple AI or where AI with really moderate performance was producing value. So we talked about things like spam filters. A very simple 2-class classifier just takes a set of documents and sorts them into 2 piles. When we brainstormed again after after sensitizing them, we produced really different ideas. Now, everything was high impact, and half of the ideas were very simple to make and deploy. And in addition, we sort of just did a much better job of getting coverage of the full opportunity space. So to give you a flavor, at first, the clinicians wanted to do things like address sedation. So when a patient is on a mechanical ventilator, you have to give them drugs so they can withstand having a tube down their throat. If you give them too much, they get delirium and PTSD. If you don't give them enough, they're in pain and don't heal well. And they wanted to use deep learning to, like, determine the right amount of sedation. We were like, absolutely not. Your data's terrible. This is really going to hurt people. And one of the ideas we shared with them was demand prediction. So this is what Amazon uses to decide what to pre-ship to warehouses. They anticipate people are going to buy something, they pre-ship it, and then when they order it, they just have a very short delivery distance. And the clinicians immediately recognized this as useful to them in the ICU. They said, hey, we order drugs every day. We could look at the patients that are here, we could predetermine what is wrong with them, and we could pre-order drugs from the ICU. This will just make us much more efficient. And the biggest risk is that you have to order drugs from the pharmacy, so it's no worse than the current state. We've been doing this process with a bunch of companies working in insurance, news, security, auditing, and accounting, and we've just been having great success with this. So I want to leave you with 5 quick takeaways. One, when you're thinking about AI innovation, don't replace an expert. Think about replacing interns, or better yet, think about, where do you have nothing? AI is definitely better than nothing, but it really works much better as an intern than an expert. In your innovation process, be explicit. Are you versioning? Are you really looking for something like in the next 6 months? Are you visioning? Are you really thinking, what is something we could do in the next 2 years? Or are you venturing? Are you really saying, we want to do a moonshot, we really want to do something 5 years out? That really, like, when an innovation team knows what they're trying to achieve, this really helps. We would definitely recommend that design functions as facilitation. They are really effective at scaffolding ideation. We don't believe everybody that's saying these things should be design-led. That's a terrible idea. Design should be an equal collaborator, but you definitely need data scientists and you need domain experts. Fourth, we would say it's really good to ideate and generate a bunch of choices, and this deals with responsible AI issues. So often when you're just working with a single idea, you run into a wall where there's some ethical problem and you're like, are we going to do this? It would be highly profitable, but it's introducing this type of harm. And that in that yes, no scenario, it's very hard for teams to make good choices. But if you can step back and say, maybe we just don't make that, maybe we make one of these other things instead of this problematic one. it really changes the way those types of issues get resolved. And finally, we've created a brainstorming kit. We think it can help you get started. We encourage you to try it and let us know if it helped you with your innovation. So that is it for me. Thank you very much.
Thank you, Professor, for your great presentation. That was very insightful for all of us. Ladies and gentlemen, we have come to an end of our sessions, and we will move forward with our awards ceremony, as you all know. And I would like kindly invite Duygu to floor again.
Bir kez
Ses gelmiyor. Evet, benimkini şey. Tamam.
ses geldi. Peki. Çok teşekkür ediyoruz. Ödülümüzü, daha doğrusu hediyemizi göndereceğiz mi beyefendiye?
Evet. Professor, do you hear us? Or you left?
Ayrıldı muhtemelen.
Okay. Ödülü o zaman biz kendisine New York'a giden olursa yoksa postalayacağız. Biz ödülleri muhakkak yurt dışı da olsa ulaştırıyoruz.
Hediyelerimizi
Herkesin
ulaştırıyoruz.
bildiği üzere. Evet, orada bir New York'a gidecek yönetim kurulu üyemiz Yasin Bey gidiyormuş. Ona emanet edebiliriz.
Tamam, peki.
Evet,
Sevdiniz burayı?
Güzelmiş.
Peki. O zaman çok teşekkür ediyoruz. Alpa Başkan Yardımcımız ve AIDEA kurucumuz size bugünün anısına bir ödül vereceğiz. Coşkun Hocam,
başkan da
buyurun
gelsin,
sizi
başkan
de
da
davet edelim. Başkanım sizi de davet edelim.
ceketimi-
Artık
dur,
son
ceketimi
ödülümüz.
alayım.
Hep
Şamlı.
beraber verelim. Ceketimizi giyelim.
Evet. Evet, dur. Bunu alır mısın? Ceketsiz şey yapmayalım, konuşma için giydik değil mi hocam? Evet, ortaya mı geçelim hocamla birlikte? Gel. Hocam teşekkür ediyorum.
Sayın Profesör Doktor
Evet,
Coşkun
başkanım.
Küçük Özmen,
Teşekkür
Sayın
ediyoruz.
Zafer
Çok
Küçük
şöyle.
Şabanoğlu,